Okay, in today's video, I'm going to solve some numericals, conceptual question from thermodynamics. First question is, which of the following is not an intensive property? Okay, so intensive property is that property which does not depend upon amount. So density of a gas does not depend upon amount, so it is an intensive property. Pressure of a gas is an intensive property because it does not depend upon what amount. Gibbs free energy is an extensive property. This is not an intensive property. So question is, which of the following is not an intensive property? So the answer is both A and C. C is correct, but A is not correct. So the correct option is C. Okay, this is the correct option because Gibbs free energy is an extensive property. These two are intensive properties. So only option for the question is C. Next question is the standard enthalpy of neutralization will be maximum for which pair of acid and base? So maximum, for maximum we need to choose, let me do flight mode before solving this question to avoid disturbances. Okay, so we need to choose that acid base pair for maximum enthalpy neutralization, which have a strong acid and strong base combination. So this is acetic acid, which is a weak acid. This is a strong base. This is not the option. ICN is a weak acid. Sodium potassium hydroxide is a strong base. This is not the option. We need to choose strong acid and strong base combination. Okay, HF a weak acid and ammonium hydroxide is also a weak acid, so this cannot be the answer. And HI is a strong acid. This is a strong acid. Potassium hydroxide is a strong base. So the correct option for this question is D. The correct option for the question is D. So if the question is asked for minimum enthalpy of neutralization, that then the answer would be C. But for maximum enthalpy of neutralization, option D is correct. Okay, let me go to the next question. The standard heats of formation of methane, carbon dioxide, this has to be water, not hydrogen. This has to be water. Okay, this has to be water. Okay, are these values in kilojoule respectively. Now the question is the amount of heat evolved by burning 1 meter cube. This is 1 meter cube of methane measured under standard conditions is. So for solving this question, this will take some time, but please bear with me and please watch the video until the end, because I'm going to solve very important questions from thermodynamics in this video. Okay, let us check the solution. We need to write the standard enthalpy of combustion reaction for methane. So this is methane. Combustion is reacting with oxygen gas, right? And products are carbon dioxide and water. So if it is balanced, hydrogen 4 2, this is the reaction. Oxygen has no meaning here, but still I'm balancing oxygen atoms also. 4 oxygen atoms in the right hand side, so this will be 2 here. Okay, so this is for burning of 1 mole of methane under standard condition. What this is for, let me calculate standard enthalpy of combustion for methane first. This is for 1 mole of methane. 1 mole means okay, here let me write here, 1 mole means 22.4 liter at STP. Okay, so burning 1 mole means burning 22.4 liter of methane. So enthalpy of combustion is for burning 1 mole of methane means 22.4 liter of methane at standard conditions. right? So enthalpy of combustion, from this reaction we need to, you know, means subtract the enthalpy of the reactants from the products, because the given values of enthalpies are for formation. So in terms of formation, product minus reactant. So enthalpy change, enthalpy of formation of what? Products minus enthalpy of formation what? Of reactants. This is the formula. Okay, so product is carbon dioxide and the value of carbon dioxide is given as minus 399, and two products are there, water, and it has to be multiplied by 2 into, because this minus is this value, okay, minus 244, minus 242, okay. These are the enthalpies of the products, minus the reactant. Oxygen has zero enthalpy of formation. For methane it is given as minus 72, minus plus, this will be plus, okay, 76.2. so this calculation or simplification comes out to be the value I have calculated, that is minus 806.8, right? This is minus 806.8 something, okay, right. This is the enthalpy of combustion, this is in kilojoule. Now what we need to calculate is the amount of work evolved by burning 1 meter cube of methane, okay. So this is for enthalpy of combustion of methane, which is for 1 mole means 22.4 liters. So this is the energy released when 22.4 liter of what? Methane is undergone combustion, right. So for 1 liter of methane, for the combustion of 1 liter of methane at a standard condition, the energy released must be this divided by 22.4. this comes out to be, I have already calculated, let me write the value directly so that we save some time. This gives the value of minus 36.1078. this is in terms of kilojoule. This is the amount of energy released when 1 liter of methane is undergone combustion. So in terms of meter cube, 1 liter is, let me write here, 1 liter is equal to 1 decimeter cube, 1 decimeter cube, and decimeter cube means 10 to the power minus 3 meter cube. So instead of 1 liter I can write 10 to the power minus 3 meter cube. So this implies for 1 meter cube this is equal to, okay, what? 10 to the power minus 3 meter cube, right? So for 1 meter cube the amount of energy released has to be this number 36.1078 must be divided by 10 to the power minus 3, means must be multiplied by 10 to the power 3, which gives the final result as what? 36108, for example. This is the final value in minus in kilojoule. So we need to choose the nearest answer, 36, 35. So the nearest answer to the option is, in the option is A must be the answer, okay, right. Let me go to the fourth question. This is enthalpies of combustion of methane, C2H5 and C2H6. Methane, ethene, and what? Ethane are 860. This has to be minus, okay. This is printing mistake or writing mistake. Minus 890, and this is minus 1411 and minus 1560. Enthalpy of combustion has to be negative, remember, okay. Kilojoule per mole respectively. Which has the lowest fill value? Fill value means calorific value, and the calorific value is the amount of energy released when 1 gram of the substance is undergone combustion. So calorific value or fuel value is equal to enthalpy of combustion divided by molar mass of the substance. So lesser is the molar mass, higher will be the calorific value or fuel value, okay, generally. But we need to check because molar mass are different and the values are also different. So I think methane is the right answer because its molar mass is very less, but still let me check. Methane has enthalpy of combustion 890, and the methane, this is for methane, okay. Methane has a molar mass of what? 12 plus is 4 is 16, and this has to be divided by 16, and this value comes out to be minus 55.6, right? And for ethene C2H4, this is ethene having molar mass 24 plus 4 28, right? So its enthalpy of combustion is 1411. Let me drop the negative value here, divided by 28. This comes out to be, I have already calculated, let me check the value, 50.4. And for what? Ethane is C2H6. Oh, sorry, C2H6. This is the what? Hydrocarbon having molar mass 24 plus 6, 30. So for ethane, enthalpy of combustion is 1560 divided by what? 30. This comes out to be 52. Now let us check the lowest value, okay. We need to check the lowest value here. This is 55.6, this as the highest value, but we need to choose the lowest value, right? So for ethene, this is what? 50.4, and for ethane this is 52. So minimum value is for ethane, for ethene. So the answer for the question is not A, this has to be B, right? Answer is B, not A. Okay, let me go to the question. We need to choose the minimum value among these three calculated values, right? 50.4 is the minimum value. Okay, let's go to the fourth question, fourth or fifth, whatever. In which is a reaction impossible at any temperature? So we need to check non-spontaneous at any temperature, right? So let me give some idea about this. Spontaneous is favored by negative delta H and a positive what? Delta S. In these two condition, the reaction will be spontaneous at any temperature, not depending upon temperature, in fact. And the non-spontaneous is favored by opposite of this, means endothermic enthalpy change positive and randomness decrease minus delta S, right? When delta S is negative and delta H is positive, the reaction will be non-spontaneous at any temperature. So according to the question, choose this option. If the question says means possible at any temperature, then we need to choose this option. So enthalpy is positive greater than 0, enthalpy negative, this is the option only. This has positive and both are positive, here both are negative, so this is the answer, right? Okay, let us go to the next question. The species having 0 standard molar enthalpy of formation. Standard enthalpy of formation is 0 for all elements in their standard state, standard states, right? STD, standard states. So standard states Bromine has a instead of liquid. This is not liquid, this is gas. So zero, its enthalpy of formation will not be zero. So this is not the correct answer. Even if bromine is the element, is an element here. Chlorine is gas in standard state. So for chlorine gas, standard enthalpy of formation will be zero, but not for chlorine liquid. So this cannot be the answer also. Fluorine is gas at room temperature. So standard enthalpy of formation will be zero for this fluorine gas, right? For halogens, fluorine, chlorine, bromine, and the iodine, this is in standard state solid, bromine is liquid, and both fluorine and chlorine are gas at standard state. So for gaseous fluorine and chlorine, standard enthalpy of formation will be zero, but not for other states, right? And for bromine liquid also this will be zero but not for bromine gas. Similarly, so fluorine gas will have a zero enthalpy of formation, right? Okay, let me go to the next question. 1 mole of which of the following has the highest entropy? Entropy will be directly proportional to number of bonds, you can say, or number of atoms, or complexity. So methane has how many bonds? 4 bonds. And hydrogen gas has only 1 bond. Mercury is a liquid, its entropy will be less. Diamond is a solid, its enthalpy will be very less, in fact minimum among the 4 given. So these two are gas, we need to choose among between these two. So methane has how many bonds? 4 bonds. This has only 1 bond, so this will definitely have maximum enthalpy, maximum entropy. So the correct answer is A. Okay, next question. Which of the following is not equal to 0 in what cyclic process? So we need to choose the path function, not state function, because for a state function, the cyclic process, in cyclic process, enthalpy of formation, change will be 0 for any state function in cyclic process. So this is entropy, state function, gives free energy, state function, enthalpy, state function. So the change will be 0, but work done is a state function, not a state function. This is a what? Work done is a path function, so its change will not be 0 in cyclic process, not equal to 0. So we need to choose this option, change in work done, right? Because change of any state function in a cyclic process will be 0. This will be 0, this will be 0, this will be 0, this will not be 0, right? Okay, let me go to the next question. Standard molar enthalpy of formation of carbon dioxide is equal to. So let me write standard enthalpy of formation of carbon dioxide gas. This has to be, the elements present in carbon dioxide are graphite, carbon, graphite, right? Solid, in solid state, plus O2 gas. So this is the reaction representing standard enthalpy of formation of what? Carbon dioxide. So we need to choose the correct option. Standard molar enthalpy of formation of carbon dioxide is equal to 0. No, this is not correct. This is not 0. 0 is for those elements in their standard states, okay, which are in their standard states. Molar and standard molar enthalpy of combustion of gaseous carbon. This is not gas. This is graphite. This is solid, right? This is graphite, and this is in solid state, right? Okay, this cannot be the answer. The sum of standard molar enthalpies of formation carbon monoxide and oxygen. So in standard molar enthalpy of formation, we cannot include any compound here, so this cannot be the answer. The standard molar enthalpy of combustion of carbon, graphite, yes, this is the answer, because this is the standard molar enthalpy of combustion. This is for the combustion of 1 mole of graphite in solid state, so this is the answer, right? Okay, let me complete this video here. Please subscribe to my channel. Please subscribe to my channel. And if you have any uh, topic that you want me to make video on that topic, please comment in the comment box. I will definitely make video on it. And if you have any question, please have a photo, click a photo of that particular question from your book or from your notebook, and please write in the comment or send me to my number. I will definitely make video on that particular topic or question if I know that particular question or topic. Thank you for today. Please share this video with your friends. Thank you.